Hi everyone. So today's agenda, last class we went through this Spark architecture and how it works. So today is a kind of practical session that we are going to run to configure a Spark cluster, Apache Spark cluster, and we are going to run some basic program and see how Spark is executing from the Spark web console, because we heard about some stage job tasks. So how it works in practical. So after configuring the cluster, so we can go through that. So last class, we know what is Apache Spark. Is a distributed computing framework, and it's not mandatory that we need to install Hadoop, but if we need to take input or output to SDFS, or we need to run a Spark program on top of Yarn, and then it's a dependency. Otherwise, we can independently install Spark and work collecting files from different data source or even the OS file system. And a Spark architecture, we know that's a master-slave architecture. So there will be worker and master nodes, and worker will be, doing all the tasks. So Spark key object is the RDD, if you remember, resilient distributed data set. So whenever we load data from different data sources to Spark, so it has been distributed across the cluster, and accordingly, it will run the application program on top of that data set. And Spark execution model. So we'll go through with some small examples today. So today we are gonna design a small Spark cluster, which can be implemented for a large cluster as well. And we'll discuss the basic procedures. It's very easy, and then we'll see practically how we are going to make one cluster. So today, as we will be running different programs, and the one of the basic the important agenda is to understand how it works practically. So we will so that I already installed the cluster, so but still I will go one by one, how to do it practically, and we'll see some kind of command to manage Spark clusters, and then we'll do some exercise on Spark today also. So today, like you, I already have installed 2 virtual machines, and CentOS is running over there. So here my SSH port is 22, and if you notice that for Spark, I would recommend to assign at least 2 virtual CPU, because as I told in my first session, that whenever you are running a job, Spark will block the CPU memory. These resources it is going to block, and also no other process can access, or it might create some abnormal scenarios. So please assign 2 virtual CPUs from the virtual box, so that at least we can run our job. Otherwise it will show you that the Spark is waiting for resource and it's not starting. So the architecture is very well using these 2 virtual hosts. So we will be configuring definitely 1 master, and we'll be configuring 2 worker nodes. So within fast host, if you see, we are configuring both master and worker, and in the second host we are only configuring the worker. So whenever we will assign some job, so today we will use Spark interactive mode to see how it works, and also internally how it is distributing the job, stage, and tasks. So whenever in Spark in the execution mode, then we'll have one driver running in master and executor running on the worker to finish the job. So I mean, I hope you understand the fundamental, the concept. I mean, master, driver, worker, and executor. And so these are the key procedures. I mean, so many of these procedures we have already, I mean, went through as part of our SDFS or MapReduce, the Hadoop configuration. So these will be remain same because these are some prerequisite. And we are not going to create any additional user. I mean, we will be using the existing Hadoop user as an application user of Spark, so that from the Hadoop user we can assign sub job to Spark. And for Spark also, I mean, it is required to establish passwordless communication between master and worker nodes, because from master, so that we used to, I mean, start processes in worker node, which is a remote machine, and without passwords, it will get access easily and can run different processes even in the remote machines. So that's why it requires passwordless login as well for Spark. So up to point 10, it's all, I mean, we have done already as part of our SDFS. So that method of procedure is already with you. And now as Spark is supporting a few languages, you know, that Scala, Java, Python, and R. So we will be using Python. So definitely we need to install Python. And so whenever you install, I mean, send to a 7, you will get the Python 2.7. But 2.7 is very stable version, but there are a lot of improvement and packages are available in latest Python versions, which can be Python 3.4 or 5. So we'll be using 3.4 in our exercise. So that's why we need to install 3.4 and make sure that our program, Spark, and everybody understand Python 3.4, and it's not, I mean, creating an issue with Python 2.7. Then as we, I mean, need to pick up files or put an output file to the SDFS, so definitely we need to start the SDFS process so that we can fetch data from SDFS in Spark and do some kind of, I mean, transformation and actions. So after that, I mean, we can go into the main Spark installation. So it's about, I mean, same, and we need to upload the Spark binaries and unzip them and place it to a folder which can be accessible by all users. And then we need to configure the Spark environmental shell. And then some default properties. So last class we are discussing, I mean, how we are gonna assign the resources for, let's say, for executor resources, CPU, memory. So there are some default configurations. If you are not mentioning, so it will automatically take, or you can mention how much resources you are trying to keep, I mean, to worker, or I mean, executor or driver. So if you have a program, I mean, if you know that it's always requires that much of, I mean, resources, then you can configure in the default Spark default.conf. Otherwise, you can also specify, I mean, while assigning job on the fly. And then we need to configure the slab node. I mean, whenever we understand the slab is all about worker. In which host you want to see the worker nodes are running, in the slabs file, we need to define those nodes. And generally, this is an optional, but I always feel that it's required to, create a Spark events folder so that, the Spark can create some historical log, the program or application that you have run, so that you can see and have a flavor what's going wrong and how it ran. And then finally, after doing everything, so you need to make sure the Spark, the binaries and all that you have placed, that is owned by our application user. And for our case, it's just Hadoop, it can be any user. And then we can, Spark, we can run or start the Spark cluster itself from the master node. So, till now, do you have any question? So I am not getting any question related to this session yet. Okay.
Participants, you can ask any question up to this lesson. Mr. Niyaz Ahmed Shaun, can you ask anything?
Sir.
Yes.
Yeah.
Sir, I see that you two user BDN 01 and BDN 02. You are worker 1 or worker 2 you are using, but where is a cluster is?
Where is the, sorry, where is the cluster?
Sir, you are assigning two worker, but
right.
I can sir, I can understand properly where is master driver installed.
Right. So this is the 01 host in which we are running both master and worker.
Yes, sir, I get it. And other user also working with worker 2.
Yes, right. See, the worker 2 only, in the 02 host, we are only running the, second
worker. Sir, I have another request, sir. Sir, can you show us how connect with user 1 with user 2?
These two nodes?
How you can connect with two nodes, worker 1 with worker. I know that there are two different machines.
Right.
Please, can you show us how you connect with these two nodes?
Yes, so I have, I installed like you guys, Oracle VM VirtualBox. And if you see, I have, two CentOS hosts running in two VMs, right?
Yes, sir.
So now if you go, this setting, so I go to network. So what I did is I made one bridge adapter so that these two VM can directly pull IPs from my, Wi-Fi routers. Okay. So
yes, sir.
yeah, so if I go here, right, so these are the VM, this is the VM console. So if you see, if I see the IP address, maybe something went wrong, but it is getting, around, it's the IP is, if I'm not okay, so it's having some problem. So ideally it will get the IPs from directly from the Wi-Fi router.
Sir, you can show us it later.
No, it's just simple. I mean, it's maybe some problem in the IP network. So if you see, I'm getting one new IP, which is 192.168.0.104.
Yes,
Okay.
sir. Yes, sir.
So similarly, I mean, I should be getting the IP from the second host. So here also something wrong. I mean, something wrong in my Wi-Fi router because I'm staying at home. So when I restart it, I'm getting a new IP. So it's 105. Okay.
Yes, sir.
So I mean, my host operating system and the guest 2OS, they are in the same network, so that these two VMs can talk each other and they can also have the access of internet.
Yes, sir.
Is it clear?
Yes, sir. Clear.
Okay, thank you.
Thank you, sir. So,
Awesome. Participant, any other question?
No any question? We can go next.
Okay.
Okay.
Okay, so I mean, as we said, our assumption of the cluster would be one master, two worker, and we'll be assigning, so one additional node, we'll be assigning two virtual CPUs. So I have already assigned, let me show you. I mean, see if I go to setting and if you go to system, so in the processor, if you see two, okay, I have given two virtual CPUs in both of the hosts, okay, and that I can, so there's something wrong. I may have to log in again. Okay, so so if I see, I mean, we are having, so processor 0, processor 1, so we are having around two virtual CPUs assigned. So that's what I am just trying to show. So because it's required, I mean, whenever we'll see, I mean, running the Spark job. So for us, I mean, we use PySpark. So this is, I mean, application. This is our application. Yes, so using PySpark, we'll do some kind of basic operation today. And our Spark master port is 7077, and we can see the Spark configuration like we see in SDFS. It would be shown in 9999. And whenever we are running our application, the application details, job, stage, as well as tasks, how long it takes, I mean, if there any error and all, so we can see in a web portal as well. Sorry. So that port generally started with 4040. It might be 4041. I mean, if you're, I mean, assigning multiple jobs and your resources are sufficient to run the jobs in parallel, then you would find the ports in an incremental manner for your application. We'll follow a method of procedure. Definitely, we'll follow a procedure to set up our cluster today, and then we'll go some kind of, I mean, data frame and RDD kind of exercise, and then see, I mean, practically how we are getting jobs, stages, I mean, automatically Spark under the hood, how its money is taking about the job stage and stacks, and how it's gonna run to the executors, what is the parallelism, how much time it takes, and all. So these are some basic, I mean, how to start the overall cluster, how to start and stop the specific master and worker nodes. These are, we'll see, I mean, in today's session. And So we also interact, we also trying to interact with SDFS, and we might need these kind of commands to put and fetch file today also. So just for your reference. So I mean, if you also need to learn more, and then I have attached some good, I mean, reference, web portal that you can go through, and you can also practice at home the different kind of methodology after configuring the cluster. So now I am going to directly going to the method or procedure. I mean, how we should set up the cluster. So as I said, I mean, these are our old structure. So you definitely would have your host names, FQDN, and IP that that you have already, I mean, put into the etc host like previous. So we have provided two hosts. So one is 104 and 105. This is the host name, and this is my host fully FQDN. So this FQDN part is optional because anyway we are not running in a real host. So the host configuration is very important. So you need to check your IP address and host configuration whether it's matching. So this is our IP. So and the interface name is ENPOS3. And you can also check your, I mean, CPU configurations. Whether after assigning you are getting number of right amount of processor amount, because it's required to run your Spark jobs. And the reason is, I mean, whenever we are running the PySpark job, so there, I mean, we are creating driver and worker, and both driver and worker by default will take at least one virtual CPU. So if you assign one, it will wait, either worker will wait for one resources, so your job will not be running. That's why. Memory, yeah, management, I will let you know, I mean, how to control if you want to. So by default it will get, I mean, 1 GB, but still you can control, I mean, what amount of memory you want to assign for executor and driver, that you can control. Check your host name. So others configuration, I mean, SSH, auto login and everything. So you can follow, I mean, the previous materials that we follow for HDFS installation. So this is, I mean, Python 3.4 installation. So we are going to use Python 3.4. So if you have internet connection, you just, I mean, run this command. So it will install Python 3.4 and some other useful tools for Python. And this is the one for which, I mean, we need to install a pip. So pip, you know, I mean, it's a package, Python package manager. So as using yum, we can use different kind of RPM install, using also resolving the dependency. So pip is a tool which you can use, I mean, for Python package installation. So it will also tell you if there is any dependencies, it will automatically, I mean, install those dependencies. And so let's say for test basis, I mean, we installed a pandas, so which is useful, I mean, for data analysis. And from Python, if you need to access the SDFS, I mean, we'll see in the next class. So maybe we need to install the SDFS package first. Then from the program, you can, I mean, import required functions and libraries from this package. So after, I mean, successful installation, if you, I mean, provide, I mean, Python if you check the Python version, it will show you the appropriate version which is installed for the both machine. Please check. And not so when you install this for the first time, it won't show you the actual Python 3.4. For that, we need to do some kind of tuning, because by default the Python will be referenced to Python 2.7. So maybe you can check time being for using this code. Okay. So what we did, I mean, we did aliasing for Python 3.4 with Python, so that it's referenced to the right binaries. So we'll see, I mean, how it is done. So if I go to, I mean, the Hadoop user, the bash RC file, which always been read whenever you are logging as a Hadoop user, either automated form or manual form. So this file would be written, and it will add some paths. Let's say user bin, and we have already configured some portion for our Spark. So it's Python path. So we have set the packages path, user lib Python 3.4 site packages, and then whatever Python part it is having, it will be added here. And also for our Spark session, we'll be using Python 3.4, and that is being identified by PySpark Python. So if we are mentioning Python 2.7, so we need to mention here. So as we are using 3.4, so we have mentioned this one. And as I said, I mean, whenever we will type Python from now onwards, so that it can, I mean, reference to Python 3.4. So we have written an aliasing in the bash RC file. So let us, I mean, check that one. So, I mean, these are the configuration that we have done as part of HDFS. So I am not going to touch here. So let us keep it as it is. And so now, I mean, if you see, we have provided some required path. So user, local, Spark bin. So this is basically related to Spark. So we'll see later on. User bin, user lib. These are the things that we have added as part of Python. And this is Python path. It's generally required whenever you are going to install some packages using pip. So this is the packages path that we are trying to mention to pip, and this is the Python library that we are trying to initiate with PySpark. And this is just aliasing. I mean, whenever we are running Python command, so that it can translate to Python 3.4 plus. So this has to be done, I mean, for both the nodes, and then we can go to the Apache Spark installation. So before going to Apache Spark, so regarding the prerequisite, do you have any question? So I have skipped whatever prerequisite we have done already part of HDFS, because we have gone through all this step already. So now we just see how to install the Python and pointing the right Python versions for our environment as well as for Spark. So let me check the HDFS portion. Okay. So I can see, I have name node running here, data node also running, and for here I have data node running, and also my Spark is also running. So let me check my HDFS. Yeah, so my HDFS is running fine. So I hope you know how to, I mean, start, or I can show you later. So we can go to, I mean, directly to the Spark installation. So for Spark, so we have already downloaded the Spark libraries, right? And it has been shared with you. So this is the Spark. If you notice, it's just a tar. So you just need to jet xf, and then you can just enter. So I can have the permission in this directory. Just need to hit sudo. Okay. So it will give you the Spark. This is the output. So you can just simply, I mean, change the name to Spark, so that, I mean, during our work, it's been easy. So then, I mean, we need to move this Spark to the user local, which already I have done already. So if you see, I mean, already one Spark directory is here, so it has been done. And that's all, I mean, for, I mean, just downloading, unzipping, and placing file to the right directory, user local. So it's not a hard and fast rule you need to put in the user local, but it's a best practice that you put into the user local. And now, I mean, we can start the actual Spark configuration. That means we need to configure the Spark environment. Okay. So before doing that, we are gonna, I mean, create some development folder. So it's under home Hadoop. Then we are creating one development folder, and also we are making sure that this, I mean, home Hadoop, from where we are trying to run the Spark process. So the Spark process will be creating some temporary or permanent output for us according to the process, and those new directories should be mapped with the, I mean, group owner of the Hadoop, and that's why we are mentioning csmood g+s home Hadoop. Okay. So maybe some users who are having the permission to write under home Hadoop, if they create some folder under it, so it might have some kind of permission issue. So that, I mean, we are making sure whoever have access in this folder, so that if that user creating any folder, that folder should be mapped with the group user permission. I mean, the Hadoop user permission should be there. So that's why this command is placed. Otherwise, you might face some, I mean, some permission issues or other kind of errors. This is one folder. So maybe today we are not using that. So whenever you will use some external packages or jars from anybody developed outside, so you can also use in during your implementation. So that's we are just creating but not using today. And then, I mean, actually we are going to create the Spark environment shell, the file, configuration file from a template. So I'm just copying the template one to Spark environment SS, and I'm going to edit that. And so it has to be down also for both the nodes, worker and master. So this is, I mean, the Java home that, I mean, we know it's already installed 1.7, and Spark master web port. I mean, from where we need to see the, you can change your port according to your requirement, and then you need to, I mean, either burn your firewall rules in your network, or you need to maintain the IP tables in your Linux machine if you are having some firewall configurations. so that you can, I mean, access this Spark cluster UI and see how many worker and masters are participating. So this is Spark driver port. I mean, whenever you are launching on applications, so the executors will be communicating one specific driver port. So this is the driver port. And Hadoop home and Hadoop configuration directory we need to define, because as we are going to fetch some file, even we can write some file back to the Hadoop as well. And we are defining here Hadoop Spark master IP. So the master IP is BDRAN FDL. So it is, I am mentioning host name. So as we have configuration defined in etc host, so that it can I mean grab the IP from over there, or it can be fetched from DNS if it's configured. And now we are defining the Spark for Python. So this is what we have already defined as part of our, I mean, the Hadoop user. So it's already, it has to be done for Spark environment as well, so that Spark can understand whenever it's getting started. And this is, I mean, some class path. I mean, whenever you mention some additional libraries details, so that is by default. So if we check the Spark class path, it is already there, but I am adding some details. I mean, in future, I mean, in the future class, if we keep some jars already in this directory, so I mean, when we run our program, we don't need to reference those. So it will search in this directory and get those custom jars so that the programs can run. So this is, I mean, all about the Spark environment. So the very important things for us today is, I mean, how we're linking with our Python libraries and what is our master node that we are defining here, and also what is the port that we are gonna, I mean, manage and see what worker and masters are participating in the cluster, and also defining the Hadoop things. But Hadoop things are optional. If you are not planning to fetch any data or putting any data to SDFS, you can skip the Hadoop portion. It's not mandatory for Spark, because you may have your program running directly connected with Oracle database or Sybase or MongoDB. So and with your file system. So it's not necessary that you need to connect to SDFS. But as we have planned to show interaction between Hadoop and Spark, so we need to configure that and see how to fetch a file from SDFS. And also, I mean, we can fetch file from our base OS. So this is, I mean, about Spark environment. Now, I mean, the Spark default configurations. So when Spark programs will run, I mean, how you want to, I mean, define a Spark, how it will take the driver memory, driver CPU, executor memory, executor CPU. There are a lot of configurations available. So, I mean, so all the full-fledged configurations. So if you go to the reference, so you can see the configurations is here. So there are a lot of configurations available, which you can define in the Spark default configuration according to your need. Okay. So for today's session, I mean, first of all, we need to copy the existing template to Spark default config one, and then now we need to, I mean, try to modify. Sorry. So here also, I mean, we are defining the Spark master. So the Spark master is generally talking with 707 port, and we enabled our event log. You can disable also. So if you enable the log, you can see what happens later on. And I hope you remember the Spark serializer. So, and what is the function of the serializer we discussed, because whenever we use data set, so in the data set, there is significant improvement on how the existing, this is the best serializer generally, in general the Cairo serializer. So in data set it's used, and in background the tungsten serializer, which I mean improves a lot in terms of performance. I mean how the shuffle read write should be done, and the data shared across the networks. So the algorithm and details are much more efficient in terms of RDD and data frame. So data sets is efficient in terms of serializations. And then, as I said, I mean, you can still define the Spark driver memory and Spark executor details also. And the detail, I mean, whatever you need, all these details you can configure according to the, so this parameter you have to take it reference from here. And you can configure like the parameter name and whatever the value you want to put. Let's say, for example, the Spark driver memory here as an example, I have assigned 5G. So if you need to assign, let's say, 500 megabytes, so you just put 500 M. That's enough. And also you can define Spark executor memory. And this one, I mean, we'll discuss. So this is one executor Python shaped configuration, which is required to down different kind of characters with hashtag. So this parameter is required for our demo, but it's not common things that we generally use. So I mean, we know how to configure the Spark default configurations, and that has to be done definitely for the both worker and master node. Now we just need to define the slab. So for slab also we'll copy one standard template, and we try to, I mean, edit that slab node. If you see, I mean, as part of our plan, so we have configured both hosts, which is 01 and 02. And so if we remove one out of here, so the worker process will not initiate here, I mean, in this cluster. And then, I mean, we have defined one Spark event folder in the temporary place and given access so that any user can read write in their temporary Spark events. And finally, we need to make sure that the user local in Spark is owned by Hadoop and its group. So that's what the CS own is. And then, I mean, we can very well start our cluster. So let me, I mean, just stop the existing cluster, which is running in my machine. So has been stopped. All the processes. So putting our configuration, if we try to run, so you can run this script. We run. If you see, I mean, here it's running master, giving some, I mean, keys notification. Some keys are, I mean, it's saying to remove because there are a lot of keys. So this is something, I mean, we need to work with SSH keys. So maybe we need to remove some keys which is not being used now. In 02, so we are running worker, and then finally in 01, we are running worker. So if you put JPS, if you need to see all the Java processes. So now, I mean, this is 01 host. So master is running, worker is running, and if we go to 02, so we have worker running. So there is no master node running over here. So now, as we said that we should be able to see the. So this is our master. So if we put 999. Okay, so this is the Spark that we have set up. So we are having these two worker running live. So it is showing, you see, I mean, according to our configuration, we have 2 cores, and the memories are also being shown at around 1 gig, right? So there is no application running currently, and the URL is this. I mean, whenever an application will be submitted, we need to give this URL so that the application can be connected directly to it. But when we are running our shell, I mean the PySpark shell, so it will automatically connect to it because we have defined in our configuration. But from an external source, if we need to run, then we need to define this URL. I mean, so that it can understand, I mean, what to communicate. So this is the Spark cluster, and yes, I mean, we have already running instance of HDFS. So this is 02, that's why only data node is running. If we go to 01, so I have my name node running and data node running, and also the secondary name node is also up. So this is about, I mean, how we need to just create. So now, I mean, if we run, let me run from the master node. If we run the PySpark shell, so this is a normal Python prompt. So you see, I mean, your normal Python program will run. Okay, so but you can, I mean, additionally you can run different Spark programs. So before going to, I mean, the standard, the procedure, I mean, let us exit from here and see the web GUI. So I have initiated one, I mean, PySpark shell. If I go to this application, so there are 2 workers related to my application, PySpark shell, and so nothing has been, I mean, the executor ID, so all are blank because we have, I mean, run only the basic Python commands, so no other activity has been performed. So, I mean, before going to the Spark interactive shell and see how it works, I mean, from the installation and commissioning portion, I mean, do you have any question? Because this one, I mean, it's pretty simple. So we have to configure few files. One is Spark environment, where we need to define who is master, what is the port the driver is communicating, what is the PySpark Python library details. If you need to plan to work with SDFS, then you can give the SDFS path. And the Spark defaults, I mean, whichever is mandatory as mentioned here. And also if you need to, let's say, put some driver memory is less than, I mean, 1 gig. So by default, it will take 1 gig from you. So if you need to reduce the driving memory to let's say 256 megabytes, then you can define like this. So, and also you can define a Spark driver code executor. So by default, it will take 1. So but you can increase that, but it takes 1 by default minimum. And then you just create one step file, standard step file in the Spark config, and you define your worker node. If you're running one worker, no issues. So you can just mention remove out of anyone, and you can create the Spark events folder so that you can see the logs if you run any actual applications, Spark application. These are the standard binaries that you need to start your cluster, stop your cluster. So this is PySpark. We are running in Turkey shell, and we already have seen the configuration of master and worker nodes. And these are just showing the HDFS start stop process, and we already checked the JPS that our master and worker are running fine. So now let's see. So we have some data in HDFS. Try to do some kind of exercise from Spark. So let's see what is seen in COVID-19. So we have a file, download file. So that is already in HDFS. Let us see. The can be a big file. So this is the file. If you see, this is a CSV file, which is showing some statistics of COVID-19. If you want to, try to find out some analysis for example, any countries like Sri Lanka or Bangladesh or India. This is old data using Spark. So PySpark, when it is initialized, it will give you two instances. Earlier we discussed that it will give you the Spark context as SC, and nowadays people are also using the Spark session as a Spark. So if you use Spark object, you can also enter into the Spark area to use. So let's say some examples. So I am importing SQL context from PySpark.sql. So using the SQL context, I am going to create one data frame. So this SC object is already initialized as part of the PySpark when it started, and we also get one object which is Spark mapped to Spark session. So you can use this one or either the Spark context as an entry point to the Spark. So now if we see, this is one data frame that we are creating, TF_COVID, and we are taking this SQL context which we have initialized now and read.format. So this is a CSV file we have already analyzed, and we are trying to load the header as well. So if it's a CSV and it's tab separated or some other delimited format that you also can define. I mean, it's not that it should be delimited by only comma. And so this is our, sorry, there is some noise that coming. I mean,
Yes. Okay, it's okay now.
Okay, thank you. So, so this is the SDFS URL. So our SDFS is name node is 01, and if you remember, the port is 9000 that we have configured as part of the SDFS. And whenever we enter into SDFS, the URL is COVID-19 that we have already seen, and the file name is download 1804/2020. Okay, so we're loading. I mean. The data into the Spark data frame. It is taking some time. So as Spark we'll be having some overhead things to be initialized. So that's why if you work with very small data set, you might see, I mean, it's slow. Its nature is like that. So if you work with, I mean, larger infrastructure and large data set, then it will give you, I mean, efficient result. So this is a data frame that showing if we, so now, I mean, if we want to see at least 2 rows, right, from the data frame loaded. So we can see the schema, right? This is the date, day, month, year is also, I mean, specified so that, I mean, programmer can analyze the cases and deaths and the territories, geography, country codes, and the when the data has been updated or some reference numbers are there. Okay. So I mean, on top of data frame, interactively we can, I mean, let's say we want to select, don't see only the date, rep, and we just want to see the countries, territories. And also want to see the cases, for example. So as there are a lot of, I mean, thousands of rows, maybe it will show some 20 rows. So what we, I mean, see that we have already picked up the required columns, the data rep, and the countries and territories and cases. And you can remove some column also, you can rename the columns, you can add some columns. And so all the works that we are doing, so it's all transformation. So Spark will start working whenever we are asking. So when we are giving dot show, then it started, I mean, actually it started working. So if we give this kind of statement, for example, like this. So one data frame is, I mean, created, but it has not been saved, right? So we can, let's say, intermediate, like this. Then, yeah. So now the intermediate data set is being defined, but Spark, I mean, won't do anything until, I mean, we want to see something from here. So if you want to see the, let's say, plus 30. Yeah, so now it's showing, I mean, top 30. Or, I mean, if you want to filter some, based on some information that you can also do that. So let's say, I mean, we can do for the overall on top of the overall data frame. So let us do it for, I mean, whole country. Let's say for group by, we want to group by for all country, how many counts are there. So if you remember, I mean, this group by operation will have, I mean, shuffle read write, because it will be worked internally like a MapReduce program. So it's just showing the 20 rows. If we need to show explicitly, let's take the top 51, it will show it up. Okay. And if you want to say, I mean, for example, for India or Bangladesh, so what I am doing, I mean, we did some count, and now we are filtering for, let's say, for Bangladesh. Okay. So it's around 35, I mean, entries for Bangladesh. But if we want to see the actual details, let us, I mean, put the filter on the original data frame. Yeah, so it's, you can see for Bangladesh, I mean, date-wise, what is the dates, or if you want to see it's quick, let's say Bangladesh, using a data frame. So it will save like this. And want to see the dates number. First, we want to select the dates and our group by on top of dates and count and show. Okay, so this is, I mean, group by should be with the territories. The long statement. Around 30, 35, yes. So, I mean, if we now go to, I mean, the application portal that we are trying to show. So this is the application portal. I mean, so it's had been initiated for 4040. So we are doing many operations. So it has been, I mean, marked as a job. And whenever we are assigning a job, so it has been, I mean, already categorized by multiple stages. And if you see, it's, I mean, doing some kind of mapping, and if there is, I mean, if we can go to the right program, then we'll see some reduce program also, because all the programs we haven't, I mean, execute the group by statement. So these are the stages. And here also you can see our executors are running here, and driver is running in this environment. And we can also see all the environment variables and their values are marked is here, for whichever we have defined. So this is just, I mean, a trial. So we'll see, I mean, in standard approach, how it looks. So, I mean, we have, I mean, uploaded few. So let us just keep it here and see in our SDFS what else is there for our today's exercise. So I'll put some files in SDFS. My dear, so there are some trips available. So from trips level, trip ID, trip destination and pickup point, time, cost, some details are there for specific passenger. So if we want to see the users one in similar version, these are the user tables or user data. So for example, a ride sharing for a company, the data can be really large. So it has been, I mean, kept in SDFS. So now, I mean, we have already initialized the SQL context. So, and we are going to read the trips into a data frame, and we'd like to name this trips, so that, I mean, we can use in different purpose. So trips data has been loaded in DF trips. So now I am loading the DF user. The way, I mean, we have loaded the COVID-19 data set in the similar way we have loaded the similar format, because these are also the CSV files. So now, I mean, if we want to see what else there, so we can, I mean, it's only 4 entries are there. So it's trip ID, trip sets. So this kind of information is there. For users also, user ID, name, mobile number, and rows are here. Some are passengers and drivers. So if we need to join this information with passenger IDs, right? The user ID and the passenger IDs is common, so we can do some kind of join. And we'd like to do the join. So these DF users, I mean, this data frame, we are doing a join with DF trips, and the join common identification is DF user ID, this one, and we are doing DF trips passenger ID, and we need to do the left outer. So you can do right outer or inner join, whatever. So now we are doing the left outer, and we can see the result. So as it's left outer, so based on this user table, if it's not getting any entry, so we'll get some null there, right? So that's what is showing. If we reset our data frame, I don't know, I just can't remember. So you can do the inner join also, which will give you the only the entry for the matching part, right? So now the join data frame has been reinitiated. So now if you want to filter some, you have to do some filtering, you have to see the passenger ID which are more than 1024. So you can define the data frame dot filter, and then data frame. You access one particular columns and then define your condition, and it will show you only the passengers which are more than 1024. So like we do some filtering on COVID dataset for a specific country or region, Bangladesh, or like this it will work. And also you can run the group by statement. So the passenger, all the passenger, are having the same count of trip here according to our data set. So now, let's go to, we have done one group by operation. Let's go to the job. So this should be one, we have submitted around 1826, 17, 19. Okay. So there are some shuffle happen because we did group by. So that's why if you see them in shuffle row, RDD is here showing right there. And so these are the tasks which has been performed in different nodes, and the durations are also presented here. And we can also write down the output. So we'll see that one later on in file system. And we can filter with some column that we have already seen in COVID-19 exercise tools. If you want to create one new data frame or having only 2 columns out of that is possible. You can also run some SQL queries. So before running SQL query, you just need to so let's say if you want to run SQL on top of the joint data frame, so you first need to create one temporary view. So this one, we can give a name, join view. So it will create one temporary view so that you can run a specific query that you would like to run. So for the time being, I would like to see all the columns, and so I have created one join view from where I need to fetch this data. Okay. So if I see that what is in this new data frame, so it's all whatever we have achieved as part of the join, because I haven't specified anything. So now if I need to put some other condition, the user ID greater than 1024, something like that. So now if I need to see the updated, so TCP 1024 is filtered. So we can either do using filter, or this SQL statement can be really complex. You can put different kind of case statements, and it can be really big. So on top of data frame, if you want to run any query, you just need to create one temporary view, and then using SQL context and SQL object, you can write your query on top of that temporary view. So in many way, you can run this kind of operation. So we did some practice on data frame. Let's do some operation with RDD, which is very basic of Spark. So let's say if we need to create one RDD. So in the RDD, we are just putting some random few 5, 4 numbers. For RDD, you will write collect. So this is one actions, and when I do the parallelize, that is just a transformation. So this is the RDD objects that it looks like. So so we have one single line. So if we need to do some kind of, for example, we want to see the log bit of each number. So we can do some map. We can write our own lambda functions. So what it will do, it will reference the earlier RDD and do a map. In the map function, we define our lambda function. So what it does, it will create the logarithm value for that. So now we see the so this is also an RDD, right? So we need to put collect. So what it's saying that maybe it's not understanding the math. It should be there. So it's now creating the mapping function has been requested. So let us see the Spark UI. So we ran the second collect is here. So there is only one stage, and it's just parallelized. So if you want to see the detail of it, so it's just put the collections, and it involved 2 executors, and around 4 tasks has been initiated. So if you see the event timeline, so there are 4 tasks. Our data set has been divided into 4 tasks automatically. Okay. So that's why there are 1, 2, 3, 4. So whenever we put any big data set, so it will be partitioned across the cluster, and parallelly the processing will be done. For example, if we want to, so here the partitioning has been done automatically. Whenever we are defining our RDD, we are not mentioning how much partition we would like to do. So moving forward to the next example, now we are trying to define the partition that we'd like to do, and it's very important to know that sometimes for big data sets, so you need to do the partitioning. Let's say we define for 6 number of partitions. So we have let's say we are doing some data set, and it has been divided. Please divide with 6 partitions, right? So now I can see the collect, okay, and we can run the same logarithm function on top of the numbers as well. And see, I mean, what Spark is doing as part of that. So it's giving output very fast, if you notice. I mean, if we go there and check our Spark application log. So just click on the last one. One stage has been, I mean, defined. And if you go the event timeline, if you see 1, 2, 3, 4, 5, 6, so it has been partitioned for 6 times, and it has been distributed to, should be 2 executors, and the tasks are also 1, 2, 3, 4, 5, 6. 6 tasks has been initiated into 2 executors. The first executor, if you see, is 104. I mean, where our master is running. Sorry, the driver is running. They executed 2 tasks. in the driver node, also we are executing master. So in that executor, 104, the primary host, they have completed 2 tasks. In the second executor, they have completed 4. And we also define the parallelism whenever we are creating the RDD, right? So in data frame that we can, I mean, achieve with repartition and wall-sec. So we'll see. I mean, so this is, I mean, whenever you are working on RDD level. So partition is very important. But if you do a lot of partition, that means if you finally your output related to a group by operations, then it will create a lot of traffic in your network or cluster. So the amount of data you are dealing, the use case you are handling, based on that you need to decide. And also the memory is very important. Sometimes you will get out of memory error. So one of the solution, you need to understand what is the data size you are handling and what is the amount of data that can be transferred over the network. Based on that, you can size your RDD accordingly, and also it will also create, I mean, faster response because the data has been broken into pieces and assigned to multiple executors. So if you see the durations, we can see each task completion duration is here. Okay, so now if we take a larger amount of data set, for example, from a file, then we can compare using, I mean, giving the, let's say you have provided here 6, you can omit this one as we see. So this Spark will automatically decide, and it will decide based on what? Based on your code. So you have 2 executors and they are assigned with 2 CPUs. So that's why they are doing, I mean, 4 partitions. So, but you can also, I mean, define the partition based on your experience and the use cases, and those partition will be distributed across multiple executor, and you would get the efficiency, and also you can solve out of memory problem by partitioning your data set. But the partition should not be very high because it can create lot of, I mean, data transactions if you do some kind of group by operation. So that's what, I mean, we have seen. So now going to, I mean, the the favorite problem, right? The word count problem. Let's see, I mean, what we have kept in our SDFS. So we have to keep one names. Let us see what is in it. So there are some random words like apple, orange, mango, orange, jackfruit, or guava, apple, Pam, I love fruit, something like that. So, I mean, we had analyzed or discussed the MapReduce algorithm for that, right? I mean, how to do. So this one is basically, so data frame, as you know, that it's kind of deal with semi-structure or structure data set. But this one anyway, we have to deal with RDD, right? Because this is totally non-structured data. There is no format, just simply a text file. So this section we'll discuss more details, but for today, I mean, if we just simply try to count. So what we are doing now, we are using our Spark context object and sc.text file. So it is loading this one into an RDD name count s, and we are referencing that specific name file which has been loaded as SDFS, and we are running one flat map which will, I mean, which will instruct us how to split, I mean, this file. We split per line, okay, and within the line, I mean, we split using space, and then we'll, I mean, count the map each word. We'll give one number for each word. That is the map function. After that, we do shuffling for the same kind of word, and we do a reduce by key, which will be basically adding in a recursive manner for the same word. Right. So if we so this is an RDD, so we should use collect, right? We cannot use show. So it is, I mean, giving the, so there I is one, this is one word because we have provided, if we see the sample is, so this is one word, love is one word, like this, the mango has been recognized as tree, 1 and 2 and 3, so mango is fine. And orange 2, bam 2, okay. So now you see the jackfruit. Jackfruit is given with a space, so that's why it consider fruit 2 and jack 1. Jackfruit is not identified as a one fruit, so guava is 1, apple is 1, apple is 3, fruit is 2. So this one, I mean, we have discussed, I mean, how it works. So this one, if you need to write a MapReduce code, then you need to write the map in Java, you need to write in reduce, and it should be at least 20 to 30 lines codes in Java. So that you can do, I mean, in memory using Spark for a large amount of file also. So first you need to identify, I mean, how you are, I mean, doing the line-wise operation, and out of the line, how you are identifying the word. Then you map each word, and then for the same kind of word, you are just recursively adding the counts, right? So that's what, I mean, if we now see, I mean, how it has been executed graphically. Let's go to the job. So this is the one. So there are two stages has been identified. I mean, one is we are loading our RDD, and we do some kind of partition by, and then map the partitions. So there is one reduce by key operations is here, and on top of that there are two tasks. and the collect function is also is related with 2 tasks. So around 4 tasks, there are 2 stages, and 4 tasks has been distributed of. So if you go to the reduce by key 1, and you see in the reduce by, there will be always the shuffle read write, right? So I mean, that's what we are discussing. Whenever we will be doing some kind of aggregations, that means the common elements, the count and everything will be exist in different executor nodes. That has to be come into a common location and should be summed up. So there will be network traffic. So I mean, whenever you will do either RDD partitioning or the data frame partitioning, based on your memory assignment and strategy. So you need to think about that. If it's gonna create a lot of traffic in the network, so it also creates some kind of inefficiency. But at a certain level, it's fine if you network, because network is very faster, but you would have some limitations on your memory, so you may need to partition according to. So now we are dealing with very small amount of data size, so there is no issues at all here. So now, I mean, if we need to save our output, so you can save the text file. I mean, let's say some. So if you want to save my output to, for example, word count dot word count. Okay, let's save it here in the existing file system. So we have taken output from SDFS. Now the processing output we are saving in our Linux file system. And if we check logging into, I mean, we have ran this one from this host. We are in development, and if you see, we ran the Spark shell from this folder, and that's why in this folder the word count has been identified as an output. So, and if you see, there is one part here. Okay. And in the part, we have seen only orange, and I and mango. Where is our, I mean, other outputs, right? So that is the distributed computing. So we have a partial output been dumped in the 0, 1, right? So let us, I mean, see in the second. This is our second node. This is 0, 2. So here also we have a development folder, and we also see the word count is visible in the second node as well. And there is one temporary folder is here, and we need to go to the 0 folder. Now this is, I mean, still a directory. It's showing on class ID. Now if you see the part, second part is here. So in the second part we can see fruit, love, guava, apple, jack. So that means these some RDDs have been processed in executor 2, some RDDs have been processed in executor 1, but when he asks for the output, that has been already been requested in the shell, so we get a consolidated output. Here we are getting consolidated, but whenever we are asking for output into the file, that has been I mean, broken down 2 pieces and found in 2 different executors, right? So now, I mean, if we need to take this output in one place, right? So I am converting my RDDs to a data frame now. Okay, so now in the DF, if we see, you can run the show statement, and you see we have orange, PAM. It's already identified the 2 rows, I mean 2 columns from that RDD. So it will infer the column and the column properties automatically, but I mean, you can also define the column names and their schema later on. For the time being, I mean, so let's try to, I mean, take our output in one file. So that's why I put qual6.1. I'm defining give me output in one file. Okay, if we give 2, then it will be divided into 2. Okay, it's saying it already exists, right? So we can either force or let's say put a new file name. Okay, and we can check. So here in Hadoop, let's go to the development and check our new output underscore F. That's what we have provided, right? Yeah. So this is a folder, and this is systems file. So we don't find anything on the 01, but it showed that it's successful. So I'm just searching, I mean, where it has been saved, right? So here also in the second executors, we have one folder like this. So here I can see 0, and I can see one task is here. So let me open this one. So here you see, I mean, all the outputs have been dumped in one single location. So that has been, I mean, requested to Spark that give me, I mean, whole output in one, but still it's, I mean, we need to search for that. So if we, so generally we won't take the output in file system. Otherwise, it's a part of design from the application. So we generally write back to the SDFS or can write back to the database, and from there any application can show it even real time. And there are, I mean, two these URLs. So it has been already mentioned in the slide pack also. So you can practice the SQL programming after configuring a cluster. We will share the COVID-19 dataset as well as the dataset that we are using in the training program. So first you complete, I mean, whatever we have put it into the documents. So you can use RDD, you can understand, I mean, the way it works, and then you can also go through the others SQL programming and PySpark details, so that you are prepared, I mean, for the next assignment. So that's all for us. I mean, we'll be having more details, or we'll be processing a bit more data in upcoming classes based on that. And in the meantime, I mean, you can configure your Spark cluster and should be habituated with Python and these handling the data with SDFS, RDD, and data frame. So let's say the problem, based on the problem pattern, then you are assigned to solve. You need to identify whether you will process the using with RDD or data frame, and either you will do the data frame object related filtering or transformation, or you will directly use the SQL queries by creating a data frame view. That's up to you. I mean, how we will, I mean, do the solutions. So I mean, that's all from the today's class. So as soon as, I mean, one important thing. So I am closing this Spark session, right? So if I go here now, you won't get anything, right? So this URL is valid until you have at least one Spark application is running. Then you should be able to browse that. As I just have terminated the PySpark application, so you won't be able to see that. So that's all from, I mean, today's session. So if anyone have any question, then we can take it up. So first one is, I mean, did you check the answers sheet manually for the last exam? Yes, I mean, there are, I mean, 3 answers, which, I mean, we did automated check and manual both. So that kind of due diligence have been followed. I hope I answered your question. So, I mean, just to share you, right? I mean, how the numbering has been done. So let's say, so you have, you answered like this. Let's say anybody answered like that, the LS like this. So this will not, I mean, work, right? So you need to put, after this DFS, you need to put one hyphen, right? So then it will work. So maybe, and maybe someone is thinking I have given the right answer, why it's not, I mean, and for file creating, you put right touch and this will not work. So you need to say that where are you are creating. You can create anything, right? But at least you need to complete the command so that the answers is complete. And I made the mistakes. So answer we can share, right, Ibrahim? What is the practice, I mean, for the sharing the right answer? Hello, Ibrahim.
Yes, answer already shared and in the video. So anyone can find at the last of the video part.
Could you please show us what is the problem in configuring Hadoop in third class so that we can also debug if similar problem? Yeah. So I mean, in the third class, what happens? So there are a lot of problems. So it just, I mean, whenever we have completed the Hadoop installations, right? Then for any file system, if it is Windows also, if you create one new partition, you have to do the format. So that's what the step we missed. I mean, we just need to format the name node before starting your SDFS cluster, and that should be the first time. So if you are using now, and let's say now I have a lot of data in my SDFS, right? And if I do now format, it will delete everything. It's right. I mean, it's like whatever we manage our Windows X is same. So that format commands was missed due to, I mean, a lot of struggle that we have made with, I mean, the VM access and all. But it's just a simple step. I mean, name node formatting is required for the first time whenever you are trying to launch SDFS. Would you install and configure Spark cluster both of the server? Yes. I mean, Here, if you see, I mean, in the same machines where we are running the name node, we are running the master of Spark, and similarly, in the nodes where we are running data node, we are running the slave nodes, which is worker for Spark. So you can do that. That will, I mean, be good. And we should be install Python because as Spark is an distributed execution platform, right? So until you interact with Spark, so you won't understand, I mean, what's going on and what to do and what's the benefit. So you can do the practice and go to the URL and see how many tasks has been created, stage has been created, job has been assigned, which other executor are doing your job. So all this you can do. And yeah, so given URL, I mean, if you go through the please explain, you have given URL 999, right? So 999, you can change your port, but you just can give one port, which is not in the standard port list. I mean, you cannot give 22, 21 something, but you can give port like this, and that can be, I mean, seen from the web browser for Spark configurations. And 7077 is a different thing that generally whenever we are running the PySpark, so the PySpark, what it does, it is going to, I mean, our Spark configuration and understand who is acting as a master, and it's connecting with this 7077 port, and that's what it is able to initialize the Spark context object. So the 999 and 707 7077 purpose is totally different. I think you got the answer. So one is, I mean, for your application run and submission, another is from the management portal. Why we use two different ports? It's the same question. I think I answered. These are different purpose. That's why two different ports. How I collect the data, or from which website I collect the data. So, I mean, if you search for COVID-19 dataset, so you would get, I mean, at least 10 sources. So some are giving you time sources, time series data. Some will give you some kind of semi-structured data in CSV format that we also will share as part of this, I mean, material. So you can load, I mean, from your local file system also if you have any problem with your SDFS, and go through the data frame and the basic commands and all. How Spark is used for real-time dynamic thread scheduling in multi-core processor. Could you please share that script regarding this? How Spark is used for real-time dynamic thread scheduling. I mean, the question is very, I mean, I'm not getting correctly maybe. But what I understand that, so now, I mean, we are running a limited cluster. Generally in each virtual machine, let's say we would have minimum 8 virtual CPUs running. So in which worker, if it is running like that, and we know we have a job, and if we have understand the volume, then we can assign a dynamic number of cores to each job, so that in the cluster we can at least run some 2-3 kind of job in parallel. So it depends on your, I mean, resources plan. So that core you can define either in your program or in your Spark default, or whenever, I mean, you are running your PySpark interactive shell. In PySpark also, interactive shell also, before running, you can define, I mean, what is your driver memory, driver core, executor core, all details. But if you are assigning some, I mean, over provisioning your resources across different jobs, you will see a message that some of your jobs will be waiting for the resources, because the Spark will be allocating resources dedicatedly. Can we show this output result in some graphical form, or it is only possible in the terminal window only? So graphical form, for example, if we write back to the SDFS, right? So then, I mean, if you open your SDFS UI, a web-based, and then you can browse graphically. Is it possible to use in BDN cluster? BDN cluster is possible, but as we are having some problem last time, so it's still the main agenda of this course is to understand and be habituated with the platform and techniques, so that you can work on any production systems, because there are more to learn, but at least you know what is the things and how to interact from the basic point of view. So that's so BDN cluster. I don't know, should not be must things to learn. The question is just command of creating the file. Okay, so the question is just the command of creating the file in the Unix. Yeah, I understand. What you are trying to say, but still, we try to understand. Whether you can create a file or not. So it's better to, specify the whole command, because if you write bi, and if I do a bi, if I'm not saving that file, right, then the file would not be created. So the answer anyway is not complete. Asking about the answer sheet, I have a question. Can you share COVID-19? Yes, we'll share as part of our, the course material. So you can load COVID-19 either in your SDFS. So if you configure well, otherwise keep it in your, Hadoop directory and try to load and run different analysis on top of that data set. Configuration document, definitely. So you'll get configuration documents, the sample files that we have used for practice. Okay. Yeah, I think we have covered all the questions, Ibrahim. So if anyone still having some confusion, we can take the questions if someone is having.
Okay, so question is finished. So dear participant, if you have any questions related to this topic, can just press the hand raise button, then I will enable your microphone.
Mhm.
Vishwajit, can you hear us?
Yeah, I can hear you.
Okay.
Fine. Hello, sir. The last exam, the question was very good. It was slightly hard, but doable. But the problem was there wasn't any timer. So the once we started, there was hard to track time. So in the later exam, if there isn't any timer set up, it will be helpful for us.
Okay, if we possible, so we can take add a timer in the Google Sheet, because we have no any some MCQ model in our website at this moment. So that we
Because you can, start your one of your, stopwatch in your mobile phone also.
Okay,
yes.
thank you.
So anyone, Sayyid Abdul Latif.
Yes, I have a suggestion that in next week, from next week, our Ramadan is coming.
Yes.
Maybe the class ends at this time is close to the iftar. So
yes,
it
yes.
will be earlier,
If we
30
check
minutes.
the schedule, you can see our next class. The last 3 class is morning. Can you see? I also email. Will email you all of participant about the schedule. Our next 3 class will be held at morning 11 to 13.
Okay.
So
okay.
I think it's very nice for us.
Convenient.
Okay. Okay.
Yeah, it's already, I think, planned, right, Ibrahim? The class schedule is already planned before.
Yes. Before starting the course, we plan the schedule.
Yeah.
Okay.
Okay. Thank you, everyone. I'm just stopping my cluster. So we can, we can very well,
Okay.
yeah,
So
close the session. Yeah.
okay, so close the session today for now.
Yeah.
Thank you so much.
Thank you, everyone.